Latin square design is a helpful tool as they are used to run experiments, but require very few runs, which makes them really practical as well as being easy to analyze. For Latin square designs, each row and column are given a treatment and assigned a Latin letter each. This is primarily in a two-block factor. A prominent component of Latin square design is assuming no interaction or the variation error will be greater. Now, to set up a Latin square is a matter of randomization. Randomly assign letters to the row factors, do the same for the columns factors, and randomly assign letters to each treatment. And a common image or association with Latin square design is these is this are these matrices. A key part of Latin square designs in order to gauge estimates is ANOVA, which help determine degrees of freedom, means of square of the columns, rows, treatments, and errors. And these equations are commonly used to find the degrees of freedom using variances between columns, or also known, or MS between rows. These values can help with the F ratio to decide if you should reject the null hypothesis. Also, with ANOVA, you can check the differences for the mean values between rows and columns to see if there's any significant differences. Now, Latin square designs are commonly used in industry and can help tremendously with manufacturing, as machines can be tested to see if they produce different results and their ability to manufacture a part. This is done in conjunction with operators in time periods to see which, if any, products significantly different results which could hinder production.